This is the Gutsy Health Podcast with Janique and Tristan Roney. Hey, you guys, welcome back to the Gutsy Health Podcast. I have my co-host, Gina Warfel. Welcome,
Hey,
Gina.
everybody.
You guys, we have Benjamin Bickman here. He is the author of Why We Get Sick. And I need to give you guys a little bit of backstory before he introduces himself and all of his credentials and all that jazz. But I don't know how someone was talking about his book that was going to come out, and it was called Why We Get Sick. And it's all about how the root cause to disease is like blood glucose and glucose monitoring and insulin. And I about died. I'm like, I can't believe there's a book that's coming out about this. And I actually bought your book the day it came out. I ordered it and I love it. And it's the one that I refer to like so much. And every time I read every page, I'm like, yes, yes, yes. People need to memorize this. This book is Bible to me. It is complete Bible. So 1, please buy the book, you guys. 2, please share this podcast with your friends, because Why We Get Sick is so important for all of us to unpack and stop skirting around. We can't keep taking this subject and like sweeping it under the rug. We have to have this like come to Jesus moment with all of us, with our entire nation, and say, we have a problem and it's sugar and it's metabolic syndrome issues. So Ben, welcome. Please introduce yourself. Tell everyone why you're so phenomenal, how you got into writing your book, what you research, where you work, etc.
Yeah, sure. What a wonderful introduction. Thank you so much for the invitation. I'm delighted to be able to talk about these things. The premise of the book is maybe a good way to start. The idea is that metabolic health essentially underlies good health or disease, that when our metabolic health is in disarray, then the consequence is going to be chronic diseases. And those are what we focus on. And unfortunately, we're looking at the structure, we're looking at the building, and not appreciating the foundation upon which it is built, and that is insulin resistance. So my background, very briefly, my PhD was bioenergetics, which is just a clever way of saying that I knew a lot. I studied a lot of biochemistry, and specifically through the lens of how organisms, how cells actually obtain and use energy from nutrients like fats, glucose, ketones, and lactate. I moved from that background in energy use in organisms to focus on what happens when there's too much energy. And that, of course, led me to focus quite heavily on fat cells. And then when fat cells go bad, or when fat cells get sick, things start to happen with insulin. And indeed, things can happen with insulin prior to that. But that got me to the point where I was a professor here at BYU, a director of the diabetes lab, and teaching a class. And to these undergraduates, I did everything I could to make sure they appreciated the relevance of metabolic health in chronic disease. And that was really the justification for the book. I just thought there was enough to sink my teeth into, and it was on a topic that I thought wasn't being discussed enough. Yeah. And again, just to really point the finger at the foundation of disease, which was when metabolic function was compromised.
Can you explain to people what metabolic health is? Because that's kind of a buzzword. It could mean so many things. So can you explain what that is and how it ties into insulin resistance and why this matters?
Yeah, that's a great question, actually. And I'm glad you're pointing that out, in a way, almost calling me out, because too many terms are used too liberally. And even I might have been using metabolic health too liberally. So let's get specific. I would define metabolic health as being insulin sensitive. If the hormone insulin can do what it needs to do and when it needs to do it, that is a metabolically healthy body. And maybe I'll define that, because that's still a little vague. Maybe the perfect or simplest way of looking at it is to be metabolically flexible. Essentially, human metabolism is largely fueled by 2 energy sources, and that is glucose and fat. Yeah. And these are overwhelmingly the 2 fuels that are giving the body energy at any moment in varying levels. And the metabolically flexible person is a person who could sit down and eat a mixed macronutrient meal, a normal meal that has carbohydrates, proteins, and fats in it. And then they would shift to glucose burning mode, so to speak, where most of the body's energy is being provided by glucose. In contrast, a few hours later, let alone maybe the next morning, overnight, the body is in a heavy state of fat burning. And fat has become the primary fuel, and glucose is providing a relatively modest contribution to energy. both of those processes and all of the dynamic time in between, where the body's in glucose burning mode, then the body's in fat burning mode, and then it's shifted back and forth, that is metabolic flexibility, and it is entirely under the control of insulin. If insulin is high, the body is in glucose burning mode. If insulin is low, the body's in fat burning mode. And then the problem nowadays is that most people are living in a state of chronically elevated insulin, and this is getting the body stuck, metabolically speaking, in glucose burning. So even though they're fasting, they haven't eaten for 12 hours, they're still getting most of their fuel from glucose because the insulin won't let the shift happen. Thus, they've become metabolically inflexible. So that might be the simplest way of defining metabolic health. Are you metabolically flexible? And then that itself, in fact, is really a question of, are you insulin sensitive or not?
So do you think then, when you talk about metabolic flexibility, is the best, healthiest thing to be able to switch from glucose to fat burning, or is the ideal to be in that fat burning all the time, where you're like in a ketosis state where you're not relying on insulin? Like, what is your view of what would be ideal?
Yeah. Oh my goodness. What a great question. So this, I believe it would depend on where the person is. How's that for a terrible answer? So let me just put that in context. So if I were talking to a type 2 diabetic who was overweight, I would say, you don't need to worry about shifting between glucose burning and fat burning. All you've been doing is burning glucose for 20 years. You need to just turn on fat burning, and you need to turn it on in a big way. And so I would say you just go lower your insulin. And the simplest way to do that is a low carbohydrate diet and fasting, a mix of those. Yeah. And that would work great. If I were talking to someone who was metabolically generally okay, maybe they're a little overweight, maybe it's a woman with some infertility, but otherwise she's, normal weight. And we'll get into that later, I know. But I would say in that case, then being metabolically flexible is probably the right idea. But Gina, there's a nuance in your question that I think is quite profound, which is that you can have, I stated metabolic inflexibility as the individual who's stuck in glucose burning mode. And that is overwhelmingly the most common situation. The fact is, long-term adherence to a low carbohydrate or ketogenic diet, in a way, makes a metabolic flexibility on the opposite end, which is to say that the body is essentially stuck in fat burning mode. Now, they're not stuck, but they will have a harder time clearing glucose than they otherwise would. So if we have someone who's been on a ketogenic diet for 6 months, and then they just go crazy and eat a big chip cookie or 2 or 3, it will take longer to clear that glucose than it would have otherwise cleared. And that's not because there's something broken. It's just that they have turned off their insulin production. Right. And so the immediate insulin demand in that moment was just more than the pancreas had on hand. But it's something a person can switch back into very, very quickly. For example, if someone is adhering to a ketogenic diet and knows they have to go into a clinic and do a glucose tolerance test, my strong advice is to start eating more carbs in a couple days before, remind the pancreas what it's like to produce a big load of insulin, and they'll pass that glucose tolerance test perfectly well.
So it sounds like the body needs to practice both. It's like muscle memory. Like the body needs to practice both, like fat burning and glucose burning. But what we've done here in America is we've like hyper exercised one muscle and not the other. And then that leads further and further down this rabbit hole of like, we're now putting on weight and now we have hormonal imbalance. Am I correct with saying that? Because we're so carb dominant. Go ahead.
Yes, I agree 100%. The only thing I would add is that it's not a unique American problem. You go through the Middle East, it is so shocking. Diabetes and insulin resistance is in fact significantly more a problem in the Middle East. Almost any country in the Middle East has it worse than we do in the United States. Mexico has it worse. A couple countries, Singapore, one of kind of my second home, Southeast Asia, they have a bigger problem. And there's some very, very interesting ethnic differences in how people store fat and how sick that fat makes them at different fat levels. But nevertheless, it is a problem, most certainly, and for all the reasons you just mentioned.
So I kind of want to take a step back, and I want to talk about the medical world right now and how doctors are not emphasizing insulin enough. Because when people go to a doctor, they typically get their blood glucose checked, and their blood glucose is how much sugar you have in your blood right now. But that doesn't show the activity of is it going up? Is it going down? Is it going left? Is it going right? Like, we have no gauge of that. They hardly ever check insulin and A1C.
Well, even the A1C, a lot of people are just looking at that, and that's just an average. Like you're not even seeing the day-to-day spikes, right?
Yes, because whenever our office like requests blood work, we always ask for insulin, because insulin, it's so important. And I want you to explain to people, why is it so important that we need now, like in our day and age, we have to look for insulin, because insulin is this really key component and tells us how hard the body is working to get sugar from the bloodstream into the cells.
Right.
Let me ask both of you guys. Maybe we're getting a little too technical. Should we do a little breakdown of biology?
A little explanation. What exactly does insulin do?
And what is blood sugar? What is blood glucose? Ben, are you okay explaining that to listeners? Let's break it down really simple, and then go into why is it so important that doctors need to check insulin, but they refuse to because they've been taught off of like old systems. So go ahead.
Yeah. Oh yeah. This is right at my alley for an old professor like me. Every semester, this is how it all starts. Yeah. So glucose, you're right, Johnny, you really laid this out perfectly well, which is that overwhelmingly conventional medicine only scrutinizes glucose levels, and they are looking at the person's glucose levels every year, year in, year out. They may see that, in fact, what can often happen is they see that the person's glucose levels are normal, or maybe they're creeping up a couple points, but in no way getting into what is considered a pathological or dangerous level. But what's happening behind the scenes is that there's a quiet kind of Cold War raging, and that is with regards to insulin. Now, insulin's most famous, I don't even want to say main, because it's just not fair. Insulin does so many different things throughout the entire body. What it does to blood vessels, what it does to brain cells, what it does to ovary cells. It affects every cell of the body.
And can I mention, and you said in your book, this is one of the few molecules that affects every single cell. Like most of them affect a few different parts, but this is one that influences the entire body. This is how important insulin is. And the fact that we just don't test for it blows my mind. So keep going. Sorry, Ben, keep going.
Yeah, it's bonkers. It really is. It literally affects every cell of the body. And insulin's most famous effect is largely what it does to the muscle cells, and that only in the context of glucose. When glucose goes up, it can kill you. If glucose were high around the 200 milligram per deciliter range for several hours, you will start to lose plasma volume or water from your blood, as that glucose in that water is getting pulled into your urine.
Wow.
And that's where the term diabetes comes from. Diabetes refers to the excess urine that is being produced, and that is a result of the high glucose. So if glucose stays too high, you will die. So insulin comes in and saves the day. In this role, it is very much acting the part of the hero. So glucose goes up, and when someone's eaten a starchy or sugary meal, that is incompatible with survival. So insulin comes up and essentially politely knocks on the doors of the cells, of the muscle cells in particular, opens those muscle cell doors to the glucose to come rushing from the blood into the muscle cell, and thereby lowering glucose. And insulin, having done its job, now retreats back into the background and goes back to normal fasting levels. So the control of glucose is viewed as insulin's only effect. And so the average clinician will only be looking at the glucose. And when you have a patient who has the gall to say, could you measure my insulin? They will very commonly be met with a response, why? We've looked at your glucose. We already know if your glucose is normal, your insulin is too. And yet that is absolutely more often not true, because what's happening behind the scenes is that while glucose is staying normal, it's taking 2 times or 3 times or 5 times more insulin than it used to keep the glucose in check. And that is what's been explaining the person's weight gain. That's what's explaining their infertility or their hypertension. It's so we have to shift the focus away from a marker, which is what glucose is. It's simply a marker of the true problem, namely insulin resistance. But you guys had mentioned A1C, and I just have to mention one idea or one thought of that. So hemoglobin A1C is viewed accurately as a long-term change, reflective of the long-term effects of glucose or levels of glucose in the blood. What too few people appreciate is that A1C is, yes, a marker of glucose, but it's also a marker of red blood cell longevity, because you have inherent differences in people, partly based on diet, where if a person, for example, isn't getting enough heme iron, I know that's a delicate topic, but if they aren't getting enough heme iron, it's very, very likely that they have more fragile red blood cells. The red blood cells are not living the full, say, 120 days they normally do, and maybe they're only living 100 days. And so you can have a person who's actually getting a normal A1C, but it would be like a false negative, where in fact their glucose levels might actually be higher than they should, but because their red blood cells are dying so much more readily, they just never stick around long enough to get glycosylated. And in contrast, you could have someone who has long-lived red blood cells. They just naturally live a little longer. And so it's natural that they would just get glycosylated a little more readily over time. And so now you have a person who actually has fairly normal or perfectly normal glucose levels, but because the red blood cells are so long-lived, now you're getting a false positive. So
oh my gosh,
that's just one nuance that isn't often highlighted, where someone's red blood cell status, which is very much a function of other health factors, including diet, that is playing a significant part into what their A1C levels are going to be. It's not just glucose.
That's really interesting. And I also think one thing that's really common too is it goes from like a small diabetes range, but almost, into the red, where a lot of people are like, well, my hemoglobin A1C is within the green range, so I'm good, right? Instead of like, ooh, we're creeping up, or looking at all these other markers, or just like, my hemoglobin A1C I read is in the green zone, so fine.
I'm fine, and you're not fine.
Right.
Like, we have to look at other factors too.
Right.
Yep. And you have to look at insulin, to your point initially.
Very cool. So have we touched on like insulin sensitivity, and can we go a little bit more into that? Because again, we're getting really sciencey, and I want people to understand like why we have this epidemic of insulin resistance, because yes, we are eating tons of carbs and we're only exercising one muscle, and then our cells are getting really desensitized to insulin. Why does that happen?
And before I explain the process, maybe I'll just define insulin resistance quickly, because I realize someone might be thinking, I don't even know what it is yet.
So what I always say is explain it to me like I'm 5.
Oh, for sure. Well, I'll explain it to you as if you were my own student here on campus. So insulin resistance is really, I like to describe it as a coin. That's a good analogy, because insulin resistance clinically, or what I'm talking about, what we're talking about, is really two things. Just like there's two sides to this coin. So the coin that I have in my hand that I'm holding between my finger and my thumb, I can flip it over and see two sides to it, but it's still only one coin. This coin is insulin resistance. On one side of the coin is insulin resistance. That is this phenomenon, this process we've been talking about, where insulin is simply less able to do what it used to do at a cell. And of course, every different cell responds to insulin differently. And so it's no surprise that when I say insulin isn't working well, that affects some cells more than others. And that is essential thing to understand when it comes to insulin resistance. It is not that every single cell isn't responding to insulin anymore. It is that some cells, indeed some big ones like muscle, which is by mass most of what we're made of with regards to tissues. So some cells do become insulin resistant, but other cells, more subtle cells, like certain cells of the ovaries or certain cells in blood vessels or on the adrenal glands, they don't become insulin resistant. They're as insulin sensitive as they ever were. And that is essential to understand when we flip the coin over and look at the other side of the coin, which is hyperinsulinemia. Well, that's just a sexy way of saying blood levels of insulin are chronically elevated. So now we have these cells that are as sensitive to insulin as ever getting inundated with insulin. They have too much. Insulin is telling them to do too much, and they can't turn that off because they are not insulin resistant. They don't become insulin resistant.
Oh, wow.
So it really we must understand both of those sides of the coin. On one hand, the selective signaling of insulin, on other, the chronically elevated insulin. That is what we have to keep in mind when we then ask the questions, how is insulin resistance causing whatever disease we're talking about?
Right. That makes perfect sense, because we always talk about insulin resistance, like you said, with the muscle cells, and because that relates to getting glucose from the bloodstream into the cells. But when insulin is in hyperdrive and it's like pushing on the cell walls of like, our sex hormones and our sex organs, it's going go, 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 instead of like go, go. So everything is in like, it goes like everything that is supposed to be going at like 30 miles an hour, it's going 120 miles an hour. And it's creating more hormone, and that hormone is creating dysfunction in another area, and it's this big domino effect.
One really great analogy that I got from another dietitian is she's like, Have you ever seen that episode of I Love Lucy where she's on the line where the chocolates start coming down and she grabs one and they're like trying to take them like as fast as they can and the chocolates keep coming faster and faster and faster. Before you know it, she's like shoving them in her mouth, shoving them down her shirt. She's like trying to do something with just getting overburdened with all this chocolate or glucose coming into the body.
Yeah, that makes perfect. Or insulin, like the insulin is coming down fast.
Up. Yeah.
Yes, and it's telling everything to work because insulin with certain cells makes them grow and it inhibits other things to stop growing. And so there's this like happy medium that we want insulin to make cells grow or stop growing in these like healthy ranges. But when we accelerate that growth, then it grows faster and faster and bigger and bigger and bigger. And the one thing that I think of mostly is like cysts on ovaries, right? Like a cyst is just an abnormal cell growth that was in hyperdrive. Right. And a lot of women that have like, can we talk about PCOS in a little bit? Because a lot of women who have PCOS have insulin resistance, but we never think about what the insulin is actually doing to like the ovaries and why those cysts are there. Well, those cysts are there because the insulin is causing certain cells to grow faster and faster and faster. And then those cysts inhibit and change hormonal function. And it's this like vicious cycle. So can you talk to us a little bit about this? And I want everyone to remember, like, the reason why we are producing so much insulin is because we're eating so much sugar and we're eating so many carbs.
Right.
And like, and this, like, I want us to eventually circle back to our way of living is not sustainable for our bodies. Like and it starts from young. Like we are downing carbs and sugary drinks and all of these things. Like we'll circle back, but
yeah. And so everyone knows that, how does this resonate? How could this resonate with you? Like, let's also touch on like, what are all the manifestations of this? Like, is it just high blood sugar? Is it PCOS? Like looking at like, what is the spectrum of having high glucose, high insulin that happens?
Yes. Like how does it affect
Who does this resonate with?
Exactly. So Ben, can you tell us about PCOS?
Yeah.
I want to talk about all those systems. Like, like let's talk about how it affects the brain and
cardiovascular,
mood and
weight, everything.
All the things. Go ahead.
So in fact, you'd asked as a part of the earlier question, and you actually brought it up again. So I'll just, you kind of slow pitched it. So I'll just hit it out here. You'd said, what were some of the origins or the why do we get insulin resistant? And you really mentioned what I consider to be the biggest one. There are three primary causes, I believe. I call them primary because as a scientist, I can use these three things to make cells in culture. Like if I'm growing cells in a petri dish, I can use these three things that I'll mention in a moment to make these cells insulin resistant. I can study lab animals, mice and rats, and I can make them insulin resistant, and even in humans. So all three of these biomedical models that scientists will use have confirmed that there are at least three key independent of each other causes of insulin resistance. One is chronically elevated stress. One is inflammation. And then the third is the one you'd mentioned explicitly, which is you're eating a diet that is forcing your insulin levels to be up all the time. And chronically elevated insulin is a cause of insulin resistance. It's almost like, well, it's reflective of a fundamental principle. When a cell is inundated with something, a stimulus, it will try to turn that stimulus off. There's just too much. And so it tries to become resistant to that stimulus. Sometimes it can, sometimes it can't. But in the case of insulin resistance, in some cells, it does. So chronically elevated insulin is a cause of insulin resistance. And of course, that's entirely a function of what you're eating. Now, you'd mentioned how insulin is promoting growth. And that is a perfect way to look at insulin at the level of the whole body, where insulin only controls glucose at a few cells. In fact, just a couple. The theme of insulin in the entire body at every cell is insulin hates wasting energy. It doesn't like breaking things down. It only wants to build things up. In fact, insulin's so determined to build up and store things that it will lower metabolic rate. It doesn't want the body to waste any energy.
Wow.
And so we can change someone's metabolic rate by up to 300 calories a day by just changing their diet to bump their insulin up or bump their insulin down.
Which, when you say change
metabolic rate.
When you say change their diet, you're saying bring down glucose intake.
That's right. That's exactly what I'm saying. Yep. So this was a study by David Ludwig out of Harvard, and he found that he could change some people's metabolic rate by 270 calories a day by just shifting the fat and the carbs, keeping the protein static, but lower the carbs, and insulin comes down, and now metabolic rate insulin comes down and metabolic rate goes up. And we published a paper last year, including human data, to find that part of that effect is that, I don't want to get off topic because I do want to get to PCOS, but essentially Insulin, when it's down, the fat rate and metabolic rate in fat cells goes up by about 2 or 3 times. So there's some very direct effects on the cells. But insulin hates wasting energy, and even to the point that it powerfully, more than any other signal, inhibits autophagy. And there's so much interest in autophagy because that is thought to be a key to aging well, that if you can undergo autophagy, then a cell can always be renewing itself by just getting rid of its old parts and replacing them with newer parts. You cannot do that if insulin is high because autophagy wastes some energy. So insulin abhors autophagy.
Can you explain to people what autophagy is really fast?
Yeah, so autophagy is just a process where in a cell itself, a cell will look within it, all of its component parts. And a cell is loaded with all kinds of exciting things. There are mitochondria, there's nucleus, there's endoplasmic reticulum, the Golgi apparatus. There's all these parts of a cell that help the cell work well.
Yeah.
And autophagy will allow the cell to scrutinize what's getting old. The cell may say, these mitochondria aren't working as well.
Yep.
I'm going to get rid of those mitochondria and I'm going to make new ones. And it can do that with any single part of itself. That is autophagy, when the cell is kind of breaking down its old parts and building up, replacing them with new ones. And insulin inhibits that powerfully. So insulin does influence the growth of tissues and the growth of cells, but not in ways people think. For example, if a guy's listening to this and he's a bodybuilder and wants to get as big a muscle as he can, trying to spike his insulin or spiking his insulin won't help his muscle growth at all. In fact, that's actually just a myth.
Wow. That was just completely a myth?
Yeah, so there was a study done in men, in college-age men, and had them exercise to fatigue. And at the time, they pulled a muscle biopsy, a small little like eraser, pencil eraser size of their muscle, and measured the degree to which the muscle grew. It was microscopic after one session, but it did. And that's a process that they call muscle protein synthesis. Then they had them eat like the best protein available, which is whey or egg whites for humans. And then they measured a significant increase in that muscle protein synthesis. Then they had them eat that protein with maltodextrin, which is just pure glucose. And there was no further growth in the muscle with that insulin spiking glucose. Insulin does not promote muscle protein synthesis. It just defends the protein in the muscle. Insulin wants the muscle to keep it once it's there. Now, I just have to mention the other study that was done because it's such a parallel to this one. Another study, they exercised, they detected growth. They gave them protein, they detected growth. And then they gave them protein and fat. And there was, in fact, significant growth beyond the protein alone. Fat and protein is more anabolic to muscle than protein alone. And I think there's something quite brilliant about the science confirming what nature or God have put together, because in nature, the best proteins always come with fat. Now, I know that might lend itself into a conversation of animal protein versus plant protein, and I know that's a very sensitive topic. I will just say, by any objective measurement, animal protein is a superior source of protein for humans. Not that you can't do it well with plant. I'm not saying you can't, but it is objectively the best. And it's interesting that the best proteins always, no exception, always come with fat. And I think there's something to take away where someone listening to this might, especially guys, we love protein powder. If that protein powder doesn't have fat with it, you're not getting the benefit you think. In fact, a lot of people who take whey protein supplements, they'll say, I can't take whey, it irritates my stomach. And part of that is because you've taken away the fat. We always look at fat digestion and bile acids, which are released in the intestines when we eat fat. We only look at those through the lens of fat digestion. But bile acids actually enhance the proteolytic enzymes or the protein breakdown enzymes in the gut as well. So usually a person who has a whey sensitivity is simply just eating protein the wrong way. And when they eat protein with fat, now they have that additive digestive benefit of the bile acids, which are only released when we eat fat, to help them digest the protein, and they don't have any stomach issues. But I've gone a long way from talking about PCOS. So
that was really interesting, though. That was interesting, though, because I was thinking like you did still need that insulin spike for the muscle building. So that's fascinating.
No, in fact, a study from University of Minnesota in the 1980s, they looked at this right at the level of the muscle cell and found that insulin provided no drive to muscle protein synthesis, but it did inhibit muscle protein breakdown.
Interesting.
And so rather than looking at insulin as an anabolic hormone at the muscle, which is how many bodybuilders view it nowadays, and which is why they abuse it, really should just look at insulin as anti-catabolic.
Yeah.
It's just it's preventing the breakdown of the muscle protein.
Wow.
And you don't need a big insulin spike to do that.
There's one thing I want to touch on this, and I want to go back to autophagy. But what you are explaining to people is, I always talk about the debate between macros and micros. You're talking about foods in their natural forms, because a lot of people, they're like, I need X amount of carbs and I need X amount of proteins. And typically they want to hike up their proteins and bring down their fats a ton. And I always tell people, like, go back to real food, like nature, put things perfectly, like packaged it perfectly together, and put all those micronutrients in there, not only to help you utilize your foods and help build, but it also puts everything in there to help with the healing and the repairing of stuff.
Yes,
so
I agree with that sentiment totally. I think the more people eat real food and the less food they're getting from bags and boxes with barcodes, the better off they're going to be.
Exactly. Let's go back to autophagy, because you spoke about insulin inhibiting a cell's ability to essentially destroy itself when it is breaking down too much. Can we circle that? I want to get back to hormones, but oh my gosh, I feel like we need to do like 4 podcasts with you, Ben, because this is amazing. This is so amazing. But how that relates to cancer, because cancer are those forever cells, like their mechanism of autophagy has been broken. And this is why we're seeing these cancer spikes, because we are pounding the carbs, we're pounding the sugars from young, mind you. I want to remind people, if you look at infant formula, it has high fructose corn syrup as its first ingredient.
Wow.
So we are pounding sugar into our infants, and we're teaching their bodies to become insulin resistant, and we're teaching their bodies to turn off autophagy, and we're teaching their bodies to create these forever cells and create cancer in their bodies. And 1 in 2 people will be diagnosed with cancer. Can you please talk to listeners about this a little bit more?
I would be happy to.
Yes.
But now you've lit another fire under me, which is baby formula. The pure garbage with baby formula is that these manufacturers, they will only seek to match the macronutrients, and they don't care what the source is. So they will say, well, breast milk has this much carb, this much fat, this much protein. So we'll just give the baby that much carb, that much fat, that much protein. Well, so most of those carbs end up coming from sugar, just like you said, as opposed to the natural milk sugars that mommy is magically making. I mean, it's an incredible thing. They're not at all the same. And the fats that mom is giving the baby is an enormous range of fats, covering an entire spectrum of medium chain fats, long chain fats. And within the long chain fats, there's countless different types. Whereas in those baby formulas, it's almost always something horrific like soybean oil, or corn
terrible.
oil,
Inflammatory oils.
Yeah.
Yep.
They are catastrophic. So anyone listening, I would say, if you can't breastfeed, do anything you can to find anything other, even something maybe like goat milk. I don't know, but something.
I've heard
with
camel's milk is the new thing. What do you think about that?
I've never heard of camel's milk, but I have heard that you can buy goat milk formula, but from Europe. Like you have to import it.
That's what I heard about camel's milk. I don't know if that. I had a friend who was importing camel's milk.
Wow.
She said it was extremely expensive. It's like you're buying gold.
Oh my gosh.
Well, I don't know that it would be worth it, frankly.
Right.
I think if it comes to dairy, goat milk's probably one of the best. Now, okay, so cancer though, because that whole infant formula was a total tangent. So cancer is there are 2 terms. So one term I've been mentioning that we've been talking about is autophagy. And that is a process where the cell eats parts of itself, but the cell itself is still a viable, healthy cell. That is not the same as apoptosis. Apoptosis is when a cell actually is programmed to die and it dies in a neat, tidy way. Every cell will undergo apoptosis at some point or another. Red blood cells are very short-lived cells. They only live a few months. Then they will die and undergo apoptosis like they're supposed to. Fat cells will live about 10 years and then they will die undergoing apoptosis. But a cancer cell is one that has mutated in such a way to avoid apoptosis. So the body is trying to tell it to die, and it says, forget you, I'm not going to do it. Insulin hates apoptosis, and that is why perhaps many cancers, especially breast and prostate cancers, which are the 2 most common, part of their mutation set, because it's always multiple mutations, is to overexpress insulin receptors. So the average breast tumor has 7 times more insulin receptors than normal breast tissue does. And so this is just making the mutation is essentially allowing the cell to respond better to insulin's growth signal. And when you combine that, so the high insulin levels and the mutation, is promoting the growth of the cancer cell, but then the cancer cell has to get fuel. And human cancer cells use glucose always, always, always. They never use fats. They never use ketones. They always use glucose. So you imagine the average American diet, which is to say nowadays the average global diet, they are living a life of chronically elevated insulin, which is accelerating the growth signal of the tumor, and they're giving it ample glucose, fueling all of that growth. And that is undoubtedly, unquestionably, an enormous reason why cancer is actually very soon to overtake heart disease as the number one killer in the U.S.
I hope that sinks in, everyone, because that is so telling of the direction our society is going. It's not getting better. It's getting worse.
Oh, no, not at all. Hundreds of billions of dollars now that we've spent on cancer research.
And we're still getting nowhere.
Almost none of it. No, that's right, because almost none of it. There are two theories to cancer, and I would encourage anyone to look up the work of Thomas Seyfried at Boston University. He's been one of the pioneers of kind of rediscovering the metabolic origins of cancer. But I just have to mention his studies very briefly. The views of cancer is that it's completely a disease of mutation in the nucleus. So genes in the nucleus have mutated.
Yes.
His paradigm is that it's a metabolic problem that arises from bad mitochondria. And his proof for this is really compelling. And so he takes tumor cells that are known, these are known cancerous tumor cells, and he can take the nucleus from these tumor cells and put them in a normal non-tumor cell, and the cell stays normal. He's just transferred the entire nucleus and all of its genes into a healthy cell, and the cell stays healthy. If, however, he transfers the mitochondria from the tumor cell into a healthy cell, that cell becomes a tumor cell.
Stop it.
That
Are you
is
kidding?
so fascinating.
It's fascinating.
I've never heard
so
that.
My gosh.
Yeah, it's a process that he's called. Anyone who wants to look it up, please do. I think he calls the cell model cybrids, cybrids. It's only when he moves the mitochondria over. Now, it's not that isn't to say now mitochondria are interesting because they contain their own little genome as well.
Right.
So it could still be a problem of a genetic mutation.
Right.
But his whole thing is that it's essentially the cancer cell has defective mitochondria, and rather than burning energy, like with oxygen in the mitochondria, now the cell has no choice but to ferment. And so the only fuel that can be used without the mitochondria is glucose. In fact, just like bacteria. And so the cancer cell starts to kind of ferment like a bacteria does, rather than burning the fuel in the mitochondria like healthy cells do.
Oh my gosh.
Wow.
So
That is fascinating.
I want to make sure I am understanding this because what the medical industry is saying is you spoke about cancers and prostate cancers having 7 times or 8 times more insulin receptor sites, right? And doctors would say that's genetic. But what we're also hearing from you right here with this research is that it's also environmental. And so this idea that we just passively get cancers needs to be debunked. Because honestly, we can only trace back about 8 to 10% of cancers to genetic dysfunctions. So the other like 90% is environmental. And a huge part of that environmental factor is sugar and glucose metabolism and mitochondrial function. What's really interesting is Gina and I in our Gutsy Health membership, we are creating a course around the order of healing, and mitochondrial function is number 2.
Mindset is number 1.
Mindset's number 1, yes. But mitochondria is number 2. And people don't understand how important mitochondrial health is. Most people don't even know what mitochondria is and how it functions and what we need to do about it. But with you just like saying this right now, mitochondria is huge. It's ginormous. It can make or break you.
Oh, yeah. Yeah, well, energy, I mean, the difference between a living human and a dead one is in large part the production of energy. The person stops breathing and now they can't burn because it is like almost a little fire. Just like a flame needs oxygen, so too do the mitochondria, where we are in a very real sense burning nutrients for energy. Energy is the stuff of life. That's what differentiates a living thing versus a dead thing. So yes, if the mitochondria aren't working well, there's no question virtually every chronic disease is waiting for you. Alzheimer's disease is in large part a disruption of mitochondria within the hippocampus, which is the memory and learning center. The ovaries have an incredibly high metabolic rate, are very enriched with mitochondria. So they need energy to go through their dynamic follicular, the preparation of follicles. One ovulates. Now you have to degrade all the other follicles lest they stick around and become cysts. So all of these life is energy. And the great beauty of our world is that when something has died, we have the ability of taking the potential energy in the remaining carbons, whether it's fats in an animal or whether it is carbohydrates that have been enriched from the sunlight into a plant. Those carbons represent potential energy that whereby a dead thing, whether we're eating the dead animal, we're eating the dead plant, in either case, it's always something dead. And it's a beautiful, I hate to say circle of life because it's so cliche, but it's this beautiful reality of this world that everything that is alive is living because something died.
Yeah.
Whether it was an explicit sacrifice made or not, there's an ethical realization that we have to appreciate. And even when it comes to humans eating animals, but even plants, everything we're eating is dead. It's something that this death can give to us to live. There's something beautiful. It's a beautiful sentiment. And I don't think it's one we should ever apologize for. We shouldn't apologize that we live because of something that died, but we should be very grateful.
Yeah.
Every time we're putting something in our mouth, we should realize that this something came from something that was once alive. Yeah. Whether it was plant or animal, it lived a life of some kind, and now its death can enrich us and help us live longer. It's a beautiful sentiment.
It's really beautiful.
It should be one that is met with gratitude.
That you don't get from eating goldfish.
Yeah, exactly. Because that's all dead. But that exchange of life, it's like this passing on of energy and, like you said, carbons and nutrients and all of that.
That's exactly right.
It's really beautiful. I don't even know where to go next.
Well,
we actually never talked about PCOS.
Oh, yeah. Let's talk about that.
And brain health. If we can talk about those two, because I think that'd be amazing. Let's go back. Go to PCOS.
Okay. So with PCOS, it's only view. I actually think the name of it is misleading, where we call it polycystic ovary syndrome. That then makes a person think, oh, well, great, my ovaries have cysts, and that's the fundamental problem. Right. When it's not. That's just a consequence or a sign of the true problem. And a more accurate term is to say that a woman would have, in this case, metabolic infertility. And that is more accurate, and it helps the person understand the true origins of the disease. The truth is, overwhelmingly, if a woman has PCOS, she has insulin resistance, even in women that are not overweight. Even in normal weight women, and this is actually something I elaborate on in the book, even normal weight women have detectable insulin resistance in their fat cells compared to other women of the same body weight and age. So it's very safe to say if a woman has PCOS, she has some form of insulin resistance. And that is where the rubber meets the road, because in her insulin resistant body, even if it's subtle, for example, at the level of the fat cell only, she's going to have higher insulin levels than is healthy for her particular body. And one of insulin's many effects is to inhibit or change the way the ovaries make sex hormones. So in the ovaries and in the testes, there's a process. There's one particular enzyme called aromatase. And aromatase is what will convert androgens like testosterone into estrogens. And that is the truth. All estrogens, which is a small family of sex hormones, there's no single hormone called estrogen, being plural on purpose. So all estrogens were once androgens, like testosterone, in every man and in every woman. It's just that a woman has so much more aromatase activity in her ovaries than a man does in his testes, that so much more of those androgens are getting converted to estrogens. And that is essential for the ovulatory cycle, where throughout the course of the month, in the woman's ovaries, either or both ovaries, there's going to be multiple eggs developing or multiple follicles. And then at a peak moment during the cycle, she will have a massive spike of estrogens. And that big estrogen surge, as a result of an LH surge, an upstream hormone, that estrogen surge is what will push one of those follicles to actually bud to the surface and release the egg or ovulate. And now that remnant little follicle, that now empty follicle, will start releasing a small little set of hormones in the area to help degrade all of the other developing follicles. It's basically saying, hey, look, I won the race. The race is over. All the rest of you now just go away. And the ovaries will autophagy and apoptose these cells. It will get rid of the follicle and those eggs and break them back down into their fundamental building blocks. But in order for all of those follicles to go away, we needed to have one single ovulation. And in order to have that ovulation, we needed to have a big estrogen spike. So if we stop the estrogen spike, we stop ovulation. And now all of those follicles that are developing throughout the course of the month stick around. And they become cysts. And so that's the origin of the ovarian cysts. But all of it, that whole process, what stops the estrogen spike is the high insulin. Insulin inhibits the conversion of androgens to estrogens. Specifically, insulin inhibits aromatase. So if a woman is living a life where her insulin is higher than it should be, one of the consequences will be that she doesn't make enough estrogens to ovulate. And now her ovaries are getting bigger and bigger and bigger every month as more and more follicles stick around and turn into cysts. And then another consequence of this all, of course, is that she has now too much androgens because the ovaries weren't able to convert them into estrogens. And then she starts experiencing some of the more obvious and undesirable consequences that go along with PCOS, which is the male pattern baldness or the more coarse body hair or the acne.
Right. That makes perfect sense. So that's why they have high testosterone. And that's why it's so that like you explaining it that way is magic.
Yeah, that makes so much sense.
And as you were saying that, I don't know if anyone else felt this, but the beautiful synchronicity of the body, like how amazing it is that when we have this like happy homeostasis of insulin, that the body is like, we are safe to reproduce. And when we have too much insulin, the body switches that off. And when we have too little insulin, the body switches that off. And by switching that off is this cascade of hormones. Like the hormones are the carrier outers. That's not a real word, but it carries out that signal. It's like, yep, we're not safe. Nope, we're not healthy enough. And then it will like shut down these processes. And insulin is that initial communicator of that.
Yeah.
And it's so beautiful.
Yeah. It's female fertility is really just almost best described as an orchestra. And insulin's just playing first violin. Where all the rest are kind of following the tempo of that kind of primary instrument. But especially female fertility, it is remarkable how complicated it is. And I think it just reflects how so many inputs, like something like insulin, can play so powerfully into this. It's because the woman bears the metabolic burden of fertility. A man has a simple, delightful moment and is, of course, involved throughout the life of the child. But the woman has to carry that metabolic burden. And so the body needs to make sure
she's safe.
It basically is saying, hey, before I commit to this, before I commit to growing this little human, I need to make sure that we've got everything we need, including, are you healthy enough to have enough energy on your own body to get and to help this fetus have energy to grow? And at the end of it all, are you healthy enough to feed this little baby once it's been born? Of course, we've circumvented that now with all these clever other foods. But essentially, is your body going to be able to breastfeed and nourish this little baby? That's why it's so much more complicated. Fertility is so much more complicated in a woman than a man. Not that a man can't have problem. In fact, I really resent the fact that if there's a couple that's infertile, we always look at the woman where, in fact, it's almost just as common. It's almost just as common that the man has the problem. It's slightly more common that it is the woman, but it's very close behind that it's the man. So, but nevertheless, the man has a simple, important role, essential, dare I say, but the woman has to finish. She's the one who has to carry this thing, the burden, across the finish line.
I want to add to it. You said insulin's kind of the molecule that says, hey, are you healthy enough to carry this metabolic process of growing a human? But another one I want to add is, are you safe and are you healthy? Because when women are stressed, cortisol like spikes, which creates a spike in insulin, right? So that's the signal saying you're actually not safe enough to procreate right now because you will probably die and so will your infant. And so as we like try to like take this home, we need to recognize as women that our stress in our society has reached like all-time high and it's not healthy. I mean, it's a huge part as to why we are infertile and why we do have these hormonal imbalances. So women, just make sure that we are doing self-care. I mean, as women, we don't do that. We self-sacrifice all the time. We hemorrhage our life force. And we think that's noble, but it's
taking
not.
supplements to just, let me take this fertility supplement without even looking at, is your body in a survival state right now?
Exactly. So are you safe and are you healthy enough to procreate?
Well said.
While we're on the topic of sex hormones, can you just kind of touch on how sex hormones actually influence our fat cells?
Oh, yeah.
Oh, yeah. Happy to. It's such a fun topic. And
This
it really is
interests a
essential to
lot of
understand-
listeners out there. I know people are like,
Yeah.
wait, what? My hormones and fat? Tell me more about that.
Oh, yeah, yeah. So insulin is what tells the fat cells how much fat to store, and sex hormones tell the fat where to store and how to store. Not how much, but just how am I going to store the fat? And if insulin's saying store fat, store fat, store fat, which it does very well, then it's going to be the role of the sex hormones to then decide, okay, you tell me to do it. All right, I'm going to do it, but I'm going to do it my own way. And indeed, the sex hormones do have their own way. And this is why a little girl and a little boy look identical, essentially, in their body type. But once they start to go through puberty, now they start to look very different.
Right.
And that's generally because the girl starts to look, of course, noticeably different. And the boy just tends to be a bigger version of what he used to be. But the girl looks so different because her estrogens are having such a profound effect on telling the body where to store fat. So fat storage on the prototypical women areas, which is like breast and hips, that is totally under the control of estrogens. If you take away those estrogens, her fat pattern goes to a very vague kind of just storing it centrally on the body. And more, like you see in a man. And this is certainly what starts to happen in the case of menopause. When a woman goes through menopause and she's losing those estrogens, now that's a natural process, and I don't want to be viewed as an advocate of hormone replacement therapy. That's a double-edged sword that I won't get into. But when estrogens naturally start to wane with menopause, then the woman goes to that other, what we would view as a typical male pattern. And that's where androgens come into play, where androgens don't really care where the body stores fat, but it ends up being just around the middle of the body. You know, whether it's visceral, like tucked in back around the organs, or whether it's subcutaneous, which is to say the fat just beneath the skin, but still all around, you know, the kind of spare tire around the sides and back and belly. So the sex hormones, both of them, estrogens and androgens, don't promote fat growth. That's an important thing because a lot of people will misunderstand and think that estrogens are actually pro-fat storage. They're not. In fact, estrogens are actually quite lipolytic. They want the body to keep fat in control. So estrogens aren't promoting the storage of fat at all. They're just telling the body where to store the fat. And in the case of estrogens, to store them in a healthy way, because you can store fat in fat tissue by just making each individual fat cell get really, really big, which is called hypertrophy, or by keeping the fat cell size quite modest, but just making new fat cells. And that's what estrogens do. Estrogens do the latter of those two. Estrogens tell the fat cells to multiply, but not ever get very big. And that's why a woman typically on her butt and hips will have an almost limitless potential to store fat. Because those fat cells, estrogens will always, I know. It's
limitless, infinite.
Yeah. Doesn't that sound so wonderful? It's a wonderful spin. But there's something very interesting there, because while that does mean a woman will virtually always have more fat than her male counterpart, she will virtually always be healthier with that fat, because hyperplasia is a healthy way to be fat, where each individual fat cell is perfectly healthy. It has plenty of oxygen. It's very insulin sensitive, which is why it can continue to store fat.
Okay, I'm glad you said that, because when you first started, I kept this in the back of my mind. You said something about unhealthy fat cells, and I was like, what's an unhealthy fat cell?
Good question.
And that's the hypertrophic fat cell. So that's the other side.
Can you explain what hypertrophic means?
Oh, yeah, for
And
sure.
what do we do to not have a hypertrophic fat cell?
So I'll bring it back just a little bit then. So as fat tissue is getting bigger, like if we saw maybe two college roommates, they graduate, they get married, they have families now, they're getting fat like everyone does. They find that they're gaining 10 pounds per year. But we could have one person who's getting fat through hyperplasia, which is what I just mentioned, where each individual fat cell is staying kind of modest size, but we're just making more fat cells. The other person is getting fat through what's called hypertrophy, which is when each individual fat cell is getting 4 or 5 times bigger than it should. And the number of fat cells is set. That's how most people get fat, certainly in most places. Now, again, the butt and hips tend to be more hyperplasia because estrogens are helping it grow that way. Is again a healthier way to get fat, but paradoxically a bigger way to get fat, because when you can make more fat cells, you do have an almost limitless potential for storing fat. When you are growing through hypertrophy, when the fat cell has gotten to about 5 times bigger than normal, it has reached a point of maximum dimension. And it essentially starts to tell insulin, I cannot get any bigger, even though you want me to. So I'm going to become resistant to you. And the fat cell becomes insulin resistant and it starts leaking fats. At the same time, the hypertrophic fat cell has been pushed so far from blood vessels that it becomes hypoxic. It can't get enough oxygen to be healthy. And it starts secreting pro-inflammatory proteins called cytokines in order to try to increase the blood flow. And so it's funny because the hypertrophic fat cell is what really drives insulin resistance throughout the rest of the body.
Wow.
Janique, at the earlier conversation, you'd mentioned the first domino to fall. That's the fat cell. But the tragedy is it's doing this in order to try to survive. It becomes insulin resistant to prevent itself from literally exploding with fat and starts leaking fats, and it becomes inflammatory, but in an effort to try to increase its own blood flow. But the rest of the body, it really pays the price for that phenomenon. So the sick way of getting fat, which is how most people get fat, most people that are considered obese have hypertrophic fat cells. It's a small sliver of the population, about 15% of people that have essentially whole body hyperplasia. And those are the people that can get fantastically obese. And I mean 500-600 pounds, where most people couldn't under any circumstance get that fat.
So is that because of the glucose?
Yeah.
Well, partly where if insulin is high, you cannot store fat unless insulin is high. It's impossible. That is why a type 1 diabetic, in fact, it's a particularly vicious form of an eating disorder in type 1 diabetics. This young girl or young boy learns in their teenage years when they're often diagnosed that if they can eat that big, enormous chocolate cake, as long as they don't give themselves their insulin injection, they can stay as skinny as they want. Of course, it's catastrophic. Their ketones will be dangerously high. Their glucose will be dangerously high, but they indeed won't gain a single pound of fat because you cannot unless insulin is high.
But everything else is like going to pot. Everything else is just getting destroyed.
So I tell my students that they die, but they look great in their coffin.
Yes. Some of like the sickest people, not the sickest, but type 1 diabetics where they look fantastic, but like their body is falling apart and they have aches and pains and they have all kinds of other issues where, you know, they want to take like pain medication all day long. And it's because of that inflammatory response. Oh my gosh. So I don't even know where to go from here because I know we're running out of time and I want to keep going. Ben, would you ever want to like come back on the podcast again?
Oh yeah, sure. Yeah,
really?
Of course, anytime. You guys, there's so much. We haven't even gotten to brain health.
No, we haven't.
Liver health.
I know.
But you guys, the tragedy is that this is what I do for 4 hours a week for a whole semester.
Oh my gosh.
We like go through every body system. So yes,
we want to sign up for your.
I want to sign up for your class,
and we want to get enrolled.
I don't even take the exam. I just want to like show up
No, you don't.
and listen, and I will pay for that. Like I don't care if I get an F. I just like, can people just sign up for your class, or do we have to do like the whole ecclesiastical endorsement thing?
Yeah, you can't. You got to be a BYU student.
All of this is just, people need to understand this. Like, it's so complex, but like the solution is so simple. Do you know what I mean? Like,
I do. In fact, but the simplicity does not imply how easy it is, because when you ask someone to start changing, you guys know this better than I do, because you actually put these things into practice, and I just sit in my ivory tower and wonder about them. But when you give someone a simple idea, I am always quick to say, but that doesn't mean it's easy, because you're asking someone to change their habits, and that is hard.
Right.
So I am sure you dive deep into this in your book, helping people figure this out. If you had like one tip that people could start doing, like what is the one step that they could take?
Yeah, it's hard to just point to one. So let me just give what I consider to be 4 simple rules, but simple doesn't mean easy, of course.
Right.
So the first rule is control your carbohydrates. And I'm not saying don't eat them. I'm not saying that at all.
Right.
Some people want to think I'm saying that, but I'm not. Carbohydrates can be a wonderful and delightful part of smart diet, but we have to control them. So you can't get carbohydrates from bags and boxes with barcodes. And in general, I would say, and I know this is a polarizing subject, but I would say be very careful with grains and be very liberal with fruits and vegetables. That's kind of my very simplistic way of really focusing on the best carbohydrates that are going to be the most nutritious and have the lowest effect on insulin.
Yes.
And then the second rule, prioritize protein. Make sure you're getting enough high quality protein to facilitate maintaining muscle and bone mass, because even bones without protein become brittle like chalk. They need that protein to help the bone be a little dynamic and have a little bit of give, lest they just become brittle and break. And the third rule is don't fear fat. Humans have an honest to goodness biological need for fat.
I'm so glad
if we don't get certain fats, we die. Focus on fat. It has little to no effect on insulin, and let it come as nature intended, which is always with something else. So I'm not an advocate of people just adding fat to their coffee or their tea. Not that can't be done well, but fat is supposed to come with other foods,
and fibers,
especially protein, or whether it's some oil vinaigrette on a salad. Fat is supposed to come with food, but don't fear it as long as it's a real fat, and that is fat from animals and fruits. Fruit fats are coconuts, avocados, olives. We as humans have been eating those fats for millennia because all our ancestors needed to do was scoop the flesh of the fruit out and squish it or press it, and then you'd get the oil. And that is not the same thing as oils from seeds like soybean and corn and canola. I discourage the consumption of those for many reasons that we can get into another time. And then my last rule is don't feel like you need to eat all the time. Fast.
Yeah. Fast. I love that. I love that so much. Ben, this has been mind-blowing. So amazing. You have a book, Why We Get Sick. You guys all need that book. It needs to be Bible to you. Yeah. Maybe not. Like nutritional Bible. Keep your other Bible, but use this as your nutrition Bible. It's every page. I feel like I could just highlight every single page because I am just like, yes, 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 all the time when I read that. Then how can people find you and learn more from you and just get all the incredible knowledge that you have to share?
Yeah. Thank you guys. Thank you so much. You're such a gracious host. I've really liked this. It was a wonderful conversation.
Oh, thank you.
I'm fairly active on social media, which is to say not as much as many people are. Mostly that's Instagram. And I just try to put out 1 or 2 times a week, a brief little video snippet of just whatever metabolic idea.
And they're brilliant, by the way. They're all brilliant, you guys.
That's great. I'm glad to hear that. It's just really my effort to kind of break down the wall that separates science from the public, especially nowadays more than ever. There's such a misunderstanding of what science is.
I know.
And I hear all of these heartfelt, sincere claims of we believe in science. And I hear those claims and I think, then you're not a scientist anymore because science is the never-ending pursuit of truth. Yep. And you have to be prepared to drop your theory at any moment. It's too many. The moment a scientist has become a rock star, then he or she is probably not going to be honest or humble enough to challenge their own theories. And they become too married to their idea and they just become nothing more than an evangelist of whatever scientific idea they may have in their minds. Anyway, I hope I never step too far, but that's really what I do on social media. People also can find some blog and video content at a website called Get Health, and that's spelled HLTH. And that's also where someone could find more about a meal replacement shake that I helped design. Essentially, and not to sound like a shill, so I'll be brief, when someone starts to adopt a low carbohydrate diet, it does mean they have to start planning and preparing meals. So this was just a way to kind of make it a little easy, kind of on the go, a way to get good protein, good fat, and controlling the carbohydrates. And so those are it. So of course, my main time is always spent publishing, and we're including some fascinating studies we're doing now on Alzheimer's disease and energy use in the brain. But that will be a topic for another time.
That will be our next podcast with you, if you're down for that, Ben, because
sure, you bet.
We have to talk about brain health. And it's one thing that's overlooked. Even by me, I'm sad to say that even in the order of healing, brain health is number 7. It's the very last step.
You can't really get a firm grip on it, to be honest.
Yeah.
If you're doing other things like getting your mitochondria in order and improving insulin sensitivity, brain health is something that's going to generally just follow those.
It does. Right. If you do all the other steps, brain health just works for you. That's not something you have to actively go out and do something. If you check off all the other boxes.
We're looking at mitochondria, the gut, the hormones,
the liver,
everything.
All the things. Oh my gosh. I cannot wait for this episode to come out. Ben, you are phenomenal. And I can't wait to interview you again. Please buy his book, you guys. Please follow him. Soak up all his juicy knowledge that he has, because he is literally a walking, talking encyclopedia of biochemistry. that all of us are missing.
Well, what's great is he knows the biochemistry, but he can break it down in great analogies. So thank you. That's so appreciated.
Oh, my pleasure. That's so
an
nice
art.
of you guys. My
That's
pleasure.
an art in of
it's
itself.
the only thing I know anything about, so I'm glad to talk about it.
Well, we love it. You're so our people.
You really are. And listeners, thank you for listening today. And we hope you enjoyed this as much as we did. And we'll see you next week. Bye.